Okay, hello and welcome. Today is going to be one of our few lectures where we're going to cover getting started with Unity, intro to it, etc. By the end of the day, you should have a good grasp on moving around, and this is probably one of the areas where the tutorials for Unity are the crappiest. So hopefully this helps you out. You're welcome to just work on your game if you're not interested in this lecture, so feel free to go on a Discord and not pay attention to me if you want to just get rolling. You can always watch this later too. The video will be out. I'm going to turn off the camera for most of this because Unity's already crowded enough without you seeing my beautiful face there, so let's go. Okay. Oop. That's an echo. I don't want that. How's that? Looking good? Looking good. Alright. And here we go. Alright, first off, if you haven't already installed it, the easiest way is to go through Unity Hub. Just make sure everybody has the same version. So you can go to your Installs tab here and install other releases from here. I prefer the 2020 long-term service branch to the latest one, so the LTS branch, but it's up to you. Whatever everybody else in your team is using is fine. But that's what I got in case you want to sync up with me, and then everything I really develop, I develop in 2019 because I haven't upgraded in ages. And talk about collaborating a little bit. So there's this Unity collab thing out there. It's Unity Teams now, I think they call it, and it's okay. I've used it a couple years ago, and I was never particularly impressed with it, so it's up to you if you want to give it a go or not. I'm not particularly a fan of it, but maybe it's gotten better since the last time I used it, so feel free to give it a shot. What I would suggest that you do if you're working with anybody is that you should make a GitHub or GitLab for your scripts folder. So the first thing you want to do when you're organizing your project, in that assets root folder, make sure that you make a new folder and put all of your scripts in it. So I've already got it here. It's my folder called scripts. And somebody said, what do you do the first time you open Unity? You have that license error. So you need to activate a license before you can use any of the versions. In the beginning, it'll ask you if you want to activate a personal license. You can do that. The personal license will give you access to Unity Personal, which finally features the dark skin for free. But if you want to use some of the pro features and you're not interested in publishing commercially, you can apply for the educational license, which is actually Unity Pro, but without the ability to publish commercially. You actually are allowed to publish commercially on the personal license, so as long as you make less than a certain amount of revenue. So yeah, you can give Unity Education a try. All you have to do, I think, is give them your email and register it. But until you do that, you'll have this banner at the top that bothers you whenever you try to open something that tells you you can't open a project till you activate a license. So just activate the personal one or the education one to get started. Yeah, feel free to interject with any other questions you have along the way. Okay, so getting started, I talked about the scripts folder, but let's do a quick tour here of just the general area of Unity here. So over here you have your scene hierarchy. And if you're familiar with object-oriented programming, and by the way, sorry, you can't make the font bigger, so it is what it is. So over here you have your scene hierarchy, and if you're familiar with object-oriented programming, the scene is always the top level thing in the hierarchy, and that's something to keep in mind. Sometimes we talk about the scene as the world. Okay, so when we're talking about world space and stuff, we're actually talking relative to the scene. And the scene is the only object in the scene that doesn't have its own transform, because the scene isn't physically positioned anywhere. Everything is physically positioned in the scene. Somebody asked, would we just have to email assets other than scripts if we use GitHub? So to synchronize your art assets, probably yes. There's not really a great way to synchronize your art assets, which is why you're pretty much starting with gameplay first. But you can also make a folder for your prefabs, which we'll get into some more later. And Unity is pretty decent at synchronizing those too. With Unity Collab, that's usually the biggest issue that I had with it, would be that you tried to sync up prefabs between different people, and like they just wouldn't show up, or they'd be missing components or something. And same for different scenes. So one of the things that you really ought to do if you're collaborating is that every different person who's working on the project should have their own scene. that they do all their work in, so kind of call it like their working scene. And then when you're actually going to merge, when like you're ready to commit your work to the rest of the team, you drop your work into the scene, and then you let everybody know what assets they're going to need and have them merge those assets into their main scene as well. So the prefabs and the scripts will be the main thing to sync, but when you get to the art assets, yeah, you're probably going to have to export and import them manually. And the easiest way to do that is probably through the editor here. We'll go over that in a bit, but there's an export functionality. You'll probably take all of your assets, export them as one bundle, so again, helps to have all your assets in their own folder, and then you'll import them on the other end. So one person on your team is probably going to be in charge of that when you get to that part, the integrating everything together. Okay, so when you start the Unity editor, you're going to have one camera. I renamed it to Sun here. And what I like to do is make another camera right away, and I call it Moon, and I just move it somewhere up in the scene but in another direction, and then I rotate it so that it's facing the opposite direction. We'll see why this is helpful in a second. And then otherwise, you just have a camera, which I renamed to static camera, and then you probably start with nothingness. You probably noticed that you have this kind of sky texture in the game preview window. By the way, I think the default that starts is that the game is a tab here. If you have a large enough screen, I prefer to have the game be its own thing, so I just kind of stick it out somewhere else on my screen. I like to have it down here next to the console. You don't need a giant console. And this is going back to what I said, doing it with a small screen is pretty terrible. Somebody asked, what's to stop you from using the Unity starter projects? Feel free, but they all suck, so it's up to you if you want to deal with them. They're not bad, but they're not great. This is a blank 3D project, essentially. So when it asks you what kind of project you want to make, I started with a blank 3D project. You have like 5 options when you go to Unity Hub and you say new project here. As a core, I just did a blank 3D there. Whoops, bye Unity Hub. Oh well. Didn't need it again today. Alright, let's add some stuff. So most of you are probably going to have some kind of 3-dimensional surface that your characters walk on. But if not, you can always use just a cube as your ground. And you can just make the cube really wide and really long. And this is the ground that your character walks on. It's just flat ground. And if you have some kind of game like you're an airplane or something and things don't actually walk on the ground, and maybe you'll turn off the render and it'll be transparent and things will just sit on it. So that's one option. The other option is to use Unity's terrain feature. Terrain is a really powerful, really advanced 3D magical thing that allows you to actually sculpt your environments in Unity. And it has a lot of caveats and limitations, but it's pretty good for some basic projects. So first of all, terrain starts relative to world space. The corner, not the center, is going to be at the center of world space. So if you look at the transform here, the terrain is at 0, 0, 0, 0, so it's at the dead center of the world. But it's actually like the corner is at the dead center of the world. And terrain's default to being 1,000 by 1,000 big. That's somewhere in the settings there. And you can change that, obviously. But let's scoot it over so that it's actually centered. So I'm going to move it over to -500, -500. And you'll notice there's a few ways to move things around when it comes to transforms. So you can just kind of hover your mouse here, click it, and then move it left to right, and that lets you wiggle things back and forth as much as you want. You can actually click into the square and punch in your number. That's usually my preference. And you can also move things in the inspector, which is my least favorite way of doing it, because you'll usually misclick something like 90% of the time. And that's basically it for moving things around. The same thing with rotation. You can click in there and spin things. Terrain doesn't really rotate, you'll notice. It's an interesting feature, one of those caveats we talked about. But all right, that's terrain in a nutshell. And that's moving things around in a nutshell. We're going to give our terrain some features here, just to show you some of the powerful things you can do with terrain, and also because we're going to demonstrate movement today, and I want it to be in 3D. So I'm going to click the brush and then look for some of the cool options I have. I'm going to do with, let's go with raise or lower terrain, and it's going to show me a little preview of what that looks like, which is sweet. So whoopsie daisy, that's a little too big, isn't it? Let's crank down the opacity and just mess around with making some lovely mountains and a hill over there. Let's do some stuff over here. Moving around the editor is something that's going to take you a lot of finesse. It's just second nature to me, but various combinations of Alt and Shift and the left and right clicks control whether you're going to pan the camera or move or whatnot. Middle click as well. If you don't have a mouse with middle click, you're going to have a very bad time moving around the editor. That works for laptops too, so it's rough to move around with a trackpad, but all this crazy crap I'm doing, I can really not explain it to you very well, but you'll get the hang of it. If you've ever used 3D art software before, you'll probably get the hang of it there as well. Let's make some more mountains. Mountains, little hill. Trying to make that kind of like a ramp. Okay, and now it's kind of lumpy, right? So I'm going to go to smooth height, and I'm going to just run that over everything real quick and make it nice and smooth. Okay, cool. I've got some smooth, lumpy lumps. And let me show you what I had earlier for my demo. This is the real terrain that I made. It's about the same, right? So it doesn't matter which one we use. When you uncheck something in the inspector over here, that just makes it disappear from the scene, and it doesn't activate. None of its scripts do anything. Nothing happens at all until you restore it back to the scene. And this is a useful functionality, setting objects to inactive. You can do this in scripts as well to stop your objects from executing their code, to stop them from moving around, whatever. So there's lots of reasons why you'll actually turn off objects programmatically, but you can also do it when you're working just to try things on and off. Somebody asked about the license thing again, so remember at the top of Unity Hub it'll bug you if you don't have a license, so just click that and set personal license or education license in Unity Hub, and it'll let you open a project from there. Okay, so we kind of glossed over this aside from the checkbox. Let's make an object and then start talking about that some more. So the first thing I'm going to make is an empty game object. This is the easiest thing of all to make. I'm going to call everything alt because I already have a version of it since I already did it. But this is going to be player alt. So this is empty. It has no renderer, nothing. It's just an empty game object. Why would you make an empty game object? Well, actually, for a lot of reasons. You're going to have a lot of empty game objects in your scene. I guess we'll talk more about that later. But for now, let's just look at the things that you get with an empty game object. So everything in the scene, except for the scene itself, remember the top of the hierarchy, has a transform, a rotation, and a scale. Let's center this guy in the middle of the scene, okay? If you double-click on an object in the hierarchy, it'll take you there. Double-click it again, and it'll zoom on him. That's a really useful feature for moving around, especially as you get the hang of panning and glossing over everything. Okay, so let's add something that's actually visible to this guy. I'm going to add a 3D object, a capsule. All right, you'll notice that it's appeared in the scene, my beautiful capsule. I'm going to call this guy the player. No, what did I call him before? Let's use a similar name. Let's call this the player controller alt, because this is going to be a demo of the care controller. So let's look at the things that come with a basic capsule. So you've got the mesh filter. This determines what 3D asset is actually used for its sculpt, so its shape. If you were to change it, obviously you're getting different assets here, right? So that's pretty straightforward. All of your advanced art assets are going to use advanced meshes probably, unless they're sprites, in which case they're actually just pictures on a flat surface. But every cool 3D thing is going to have its own mesh, actually probably a series of meshes. And then you've got your mesh renderer, which if you uncheck, it disappears. This is what actually renders the object to the scene. And this thing is made of different materials, and it also has settings that allow it to do things like cast and receive shadows, etc. You can see that different things happen when you turn the shadows on and off. That's all pretty straightforward, but you'll see more about that later. Now, if I wanted this thing to have a custom color, which I do, because I'm going to have a few later, you would have to make a new material. So I've got my colors that I imported here. I actually just made these in paint.net. Let me just show you how I did these, because it's not particularly challenging. You do it in Paint too. Alright, so I'm going to make this canvas a fixed size. We'll go with 800 by 800, and I'm going to paint a color. Let's go with red. This is going to be red.png. Lovely. Okay, that's red. Then I'll find it. There's my red. I will import it to Unity by just dragging it into my Textures and Materials folder. Now I've got my red two-dimensional art asset. Okay, I clicked alpha as transparency because that's going to be used for most PNGs, but we'll talk about that way later when we do art. Then I'm going to make a new material. I'll call it red. Every three-dimensional object has a material. I'm going to drag red onto the albedo, which is the most basic way to color something. And then I can just drag my red material onto the game object I want to color, in this case my little cylinder guy. Alternatively, I could have just changed his material down here, so let me undo that. And then go back and see he has the default material here as his material. I could have just changed that to red as well, but I like to drag things on there. Here we go. Alright, so now the capsule is red. Somebody made fun of paint.net. How dare you. Alright. Well, we got a problem here, right? He's in the ground. Okay, so we want to get the character out of the ground, obviously we want to start him inside the ground. So you have a couple choices. You can move the parent object up, and you'll see that as the parent moves, remember this player character controller is a child of player alt. They're in the hierarchy together. As the parent moves, you'll see so does the child, but look at its Y position, right? So as I move the parent back down to 0, let's say, the player character controller's Y position stayed the same, it's still 0. And that's because the transform that you see when you're inside a child component like this is not relative to world space. Remember, the scene is world space. So when I move this guy around, I'm moving him around in the scene, and that X and Y will reflect that, okay? But when I move this guy around, I'm actually moving him relative to his parent. That's something to think about, okay? And that's going to be true of all children. This is actually really helpful. But as you do this, keep in mind that every transform actually also has an absolute position in world space, in addition to having that space, that transform that you see there that's relative to its parent. So when we do scripting and stuff and we move our different transforms around, we can move their local position, which is relative to their parent, and we can also move their absolute position, which is relative to world space. Okay, so I'm going to just do what I did on the other object. I'm going to move the parent up a bit, and there we go. That's where my dude starts. And I'll also move him off the hilly area, so we'll start like over here. Lovely. Okay, and I'm going to give him some arms just to demonstrate the power of world and local space. So let's call this his left hand. Okay, so obviously we don't want his arms to be the size of him, so how do we make them smaller? Well, we can play with the scale, of course, so 0.1, 0.1, 0.1, that's too tiny. Let's go with 0.2, 0.2, 0.2. Okay, well now it's inside of him, as you can see, which isn't ideal, so we're going to have to move him out to make him arms. Now, we want them to be in front of him, and as you have your player selected here, where are my gizmos? Yeah. Let's show this thing. Anyway, we want to move it forward relative to him. So we want his arms to be in front of him, not off to the side or something. So as you move this stuff around, like, which way is his front? Think about that. Which way is his front? Well, you can guess in chat if you want, but which axis is the forward axis? Is it X, Y, or Z? Which way is forward relative to the character? Which way is forward? If you have the little hint gizmos on, which somehow I turned off, where is this thing? There we go. If you have the hint gizmos on, forward is blue. Forward is blue. Z, right? Yeah, Z is forward and back. X is left and right. So these arrows correspond to the three primary vectors. Blue is vector forward for this object. In world space, true blue is, if you click this, it'll center you in world space to true forward. But if you're thinking about world space, so for the whole scene, blue is forward. But also for every individual object, it has its own personal idea of what forward is for the transform, and that's the blue vector, the z-axis. And then right is the red axis, okay, and then up and down is the green axis. So keep that in mind as we get on with it. All right, so if you want the hands to be in front of him, we're going to move them up on z, and then this is going to be his left hand, so it's going to be a little bit negative on x. I like to get into the habit of using round numbers for all this stuff, so I just kind of manually pick. All right, I went with 1 here. And then I'm going to copy the left hand and paste it. F2 to rename. There is actually no, there is a rename. No, there didn't used to be a rename there. It was pretty annoying. But F2 is the hotkey. And then I'm going to move his right hand to 0.3. So now he has 2 beautiful hands in front of him, like a zombie. When multiple objects have the same transform, you can multi-select them. So now I have both of these. And you'll see that the thing that they don't have in common just has a dash. But you can actually move them together on their common axis, which is really cool. So if I wanted to move both of his hands to 0.75, I could do that together. So this multi-select tool comes in handy quite a bit. Another thing I want to do here, so I have these 2 hands, but I don't want his hands to have collision. I want them to just pass through things like a ghost. So anything that has a collider is going to be able to obviously have collision. So if I don't want them to have any collision with the environment, I can just remove the collider. And since I have them multi-selected, it removes it from both. But let's talk about all the other different neat objects here, whatever these are. What is this in the inspector? So in the entity component model, everything so far that you've seen is an object in the scene. So we have our little empty game object, we have the player character controller. Objects are all organized in this hierarchy with the scene at the top. And then every object also has these properties attached to it. These properties are what we call the components. So all the little objects in the scene that you make, I like to think of those as the entities. These are all the components. Now something to consider is that every single frame, which is actually every single time the update function is called for every single object in the scene. All of this stuff does something, right? So the mesh renderer draws something to the screen, all the shadows and stuff are computed, capsule colliders are all checked for intersection, the material goes into the renderer to determine what material it's going to be, but all of these different components that are attached to every single entity in the scene is going to do something. It's going to do something effectively every single frame. And that's true of these scripts as well. So every script that's attached to an object is going to execute. So if you have 100 objects in your scene, you're going to have 100 different instances of that script firing off. Now you'll get the hang of this a little bit more later. All right, so let's get started with moving around. Before we go to that, I guess let's turn this camera off. Let's try starting the scene and seeing what happens. So I have my game preview window down here. If I click this arrow right here, it's going to start the scene. And now we're kind of playing. You usually have to click into this window to start actually using your inputs and stuff. Right now we don't have any inputs, so nothing's going to happen. But this is playing in demo mode. Now one thing to be careful of, a common mistake that people make when they're new, is that you can continue to make changes to the scene when the game is in preview mode. So like, say I move this guy over here. The problem is that as soon as you end the preview, everything's going to go back to where it was, so all your changes get erased. So this is kind of like for debugging and testing. You can play the scene and then you can actually manually move things around. Just remember that all those changes get cleared, so just make sure that you're not accidentally playing the game as you make all of your changes, because you can make tons of changes and then realize, oh, I've been playing this whole time. So keep an eye on that. Another thing to note is that the way that the game looks in this little preview window, including all the controls and the resolution and the lighting, is actually not how it's going to look when it's built finally. It looks a little bit cheesier. The lighting is done very quickly by comparison. There are a lot of differences. So when you get into the art phase, don't get too obsessed with tweaking how it looks in the game preview window, because that's not actually how it's going to look. I mentioned earlier that I like to make the moon in addition to the sun when we have those 2 initial objects in the scene. We just get that camera and the one light. If you turn off the moon, you notice the shading kind of changes here. If you turn off the sun as well, everything's dark. Let's just turn the moon back on and see what it looks like with one light. Well, I made the moon much weaker, so you see there's only like lighting on one side of the hill. Likewise with the sun, you have some shadows being cast over here. If you don't have two sources of light that are pointed in different directions, then it's easy to have places where there are really deep shadows cast. And you can see on the main character when you turn the moon off, he has like a darkened area at the top here. So it's good to have at least two sources of light to have like some semi-realistic lighting in your scene, but also just to avoid dark areas where you can't see during development, which makes it kind of annoying. All right, so let's make this guy move around. To move around, you have two main choices, right? You have your character controller and your rigid body. So we're going to go into depth on both of those hopefully today and talk about some of the downsides and upsides of both. So first I'm going to add a component to this guy. I always use the search function here because there are like literally thousands of things here. If you don't know what you're looking for though, feel free to obviously go through these and try to find it. But I don't even know what character controller is under if I had to find it like this. But if I was to type it, I could easily find character controller. If you have a character controller, you'll notice that it actually has a collider built into it. This little green outline indicates a collider. So you don't actually need the extra collider. Let's turn it off and see if it makes any difference. Just leave it attached for now. You notice the character collider has a bunch of different settings: slope limit, step offset, skin width, minimum move distance, yada yada yada. This stuff is useful. Radius and height and stuff determines the kinds of spaces that you can squeeze through. You'll notice that if you change these, it affects the size of the collider. So this affects like what you can fit under, whether you can crawl under something. Radius, obviously, if you can fit through a hole, etc., etc. The really interesting parts, and the reason why people tend to use character controllers over doing it with physics, is these step functions that you get. These allow you to automatically climb up small slopes and just step over them as if they weren't there. So when you do that with physics, you have to handle all of your slopes and climbing and stuff manually. If you do it with a character controller, you will see when I add the movement, my character is just going to be able to climb some of these slopes, no problemo. Okay, so let's get into scripting. So I'm in my scripts folder. Remember, you want to have all your scripts in the folder. I'm going to create a new script. So new C# script. I'll call it player move alt. That opens Visual Studio for me. If your computer's slow, you might have to wait 8 to 10 business years. This is what a default script looks like before there's anything in it at all. Okay, I like to do that with my parentheses there. I'll also get rid of the placeholder stuff. There we go. So start is called when an object is first born into the scene, when it's instantiated. If the object already exists in the scene like this, so we already had it in the scene to begin with, it wasn't like birthed by an event or anything, then it fires at the beginning. So if you think about that, that means, well, hold on, every single start method for every single object that I have in the scene at the start fires? Yes. And that's a pretty expensive operation. So if you put too many objects in the scene at the start, you will get some hiccups at the beginning as it tries to load all of their start methods. So accessing the character controller in your script, you have two choices. The first choice, we're going to create a private character controller. All of the different built-in components have a type in scripts too, so this is of type character controller. Here, I'll call it controller. All right. The first option is to link it in script, and for that I'm going to do this. I'm going to say controller at the start equals, and then I'll do get component. These little carets that you use indicate the type of object that you're looking for. If you're not familiar with carets, you see them a lot in modern programming languages. Even Java has them, so hopefully you've taken a class that has featured the carets so far. But if you haven't, they're just telling the get component function what kind of thing it's going to be looking for. I'm going to be looking for a character controller. Okay, so what this is going to do is it's going to start at the top of this object's hierarchy of components, and it's going to look through them until it finds a character controller, and then it's going to set controller equal to that. If there's more than one character controller, it's going to return the first one. more than one character controller doesn't make sense. But for other kinds of components, like colliders, you can definitely run into problems with this. Luckily, there's a get component that returns an array list too, so that's what you would use in those situations. But anyway, the important thing to note is that any kind of operation like this, these get operations, they can get expensive pretty quick if you have a ton of components attached. Unity is really efficient with these. It does these in a tree form, and you get to your answer pretty fast, but you can also get into some pretty expensive operations like get component in children, which is going to search all of the children of this component too for what you're looking for. And you can get component in parent, which goes up the hierarchy and searches the parent for what you're looking for. And likewise for the array versions of this. So this can get expensive in terms of your resource budget pretty fast. But for objects like the player that just get instantiated at the beginning, perfectly fine. By the way, you don't have to follow along with any of this. I'm going to post all the code when I'm done. And let me try to make the font bigger. Do. There we go. Let me know if that's still hard to see. Okay, so the other option is to do this. Make your character controller public. I can even erase this. I don't need it necessarily. And link it in the editor. So the first thing I need to do is actually attach this script to my player guy. So you can do this a couple ways. You can go to add component. You can search for your script and then add it like that, or you can just drag it on there as well in the bottom where you don't have anything yet. That was the wrong one. I think it's this one. You have a little preview of the file names down here. This can be useful too. So player move all. There it is. And we'll see in the inspector that there's this blank slot for a controller. What I want is this guy here. So I could drag this guy in like that. You can also actually take an object that you know has a character controller. So this guy has a character controller. I can drag the whole object in there, and it'll figure out that I wanted the character controller attached to that object. So this is the preferred method of doing it, rather than invoking all those different gets. But for a player object that's only going to invoke gets once at the start, this is also perfectly fine. So up to you how you want to do it. The advantage to this is that it doesn't crowd your Unity inspector, and perhaps most importantly, if you're dumb and you forget to link them, nothing bad happens. Whereas if you're dumb and you forget to link them, and it ends up being null, you're going to have a null exception somewhere down the road. Okay, so that's my character controller. He is linked now. Lovely. That triggers at the start. Now let's move on to update. Update happens as fast as it can. Essentially, it runs once at every frame, and like I said before, it's going to trigger for every single game object in the scene. So we want to get input. And a lot of you, when you were describing your projects, were talking about, like, I want to use a controller, I want to use a keyboard, whatever. Luckily, Unity doesn't care. As long as you use the universal system, and you're going to go to Edit and Project Settings to see the defaults here. Go to the Input Manager tab, and you'll see kind of some of the built-in options for the universal system. Let's look at horizontal. All right, horizontal and vertical. So horizontal and vertical are left, right, and up and down, respectively. And if I was to plug in a controller right now, it would read left, right, up, and down from the left stick. If I was to just use WASD, it would read left, right, up, and down from the WASD. Notice that there's a negative button is left, positive button is right. Okay, those are the arrow keys. But then there's also an alt negative, alt positive, so that's A and D. All right, and then it also can get motion from joysticks, that's the controller. So we can go into more detail on how to set these up, but someone asked if I froze. Let me see if the stream's still going. Nope, just you. Okay, so if you're going to be modifying an input, you're probably going to go here into your input manager and change it. The defaults are probably going to work for most of you. Some of the other stuff here, like dead zones, how sensitive the button's going to be, those are relative to the sticks. Those are things you might want to play with too. But anyway, that's what we want for our basic movement. We're going to want the horizontal and the vertical movement. So that's what they're called here. All right, let's also go into a little bit the difference between a button versus an axis. Let's see. Okay, like jump is a button. It's a key or mouse button. Let's see. Find something that's not. Maybe that's beyond us right now. We'll come back to that later. But essentially, the difference between a button and an axis is that a button is just on or off, up or down. You can also do something as it's held down. You can do something when it's released. Of course, you can do all that stuff. And an axis gives you a number between 0 and 1 for how pushed down that thing is. So that's what you're going to use for your joysticks and obviously for your mouse controls as well. So it's between the left and the right is 0 and 1, for example. Between top and bottom is 0 and 1, that sort of thing. Okay, so let's get input from those two inputs that we had available, the horizontal and the vertical. So I'll call those, consult my notes here, try not to copy. Try to name them the same things that I had them in my examples. Okay, so we're going to do stick X or keyboard X. This is input.get axis, and we want the horizontal axis. So remember, I said that Z is forward and back. That means that X is generally considered left and right, right? Okay, so that's stick X, and then let's pick up, whoops. Pick up stick Z. That's our vertical. If I spell these wrong, it's not going to work. Okay. All right, and let's make sure that these actually do something. So I'm going to debug log. Let's log stick X, space, and stick Z, and we'll see what I get. All right, when you save this, there's always like a 1 second hiccup while Unity is like, hold on a second, let me load this. Depending on how slow your computer is, if you mash that play button before Unity's done, you can very easily crash the editor, so keep that in mind. All right, 0, 0. When I press A and D, you'll see that it is a float value and it gradually increases to 1. This is kind of how Unity simulates controller sticks with WASD. It kind of just like brings them up to 1 over the course of a couple of seconds. It's an interesting way to do it. Same when I use the arrow keys. Different values between 0 and 1. You can see this in the console too if you want to watch the infinite scroll of zeros and ones there. If you hold the key halfway down and you have like an analog keyboard, you can also get it to sit there longer. But anyway, if I had a controller plugged in, you'd be able to see that I can get like full axis support there with the joystick too. So pretty cool. All right, let's get rid of the debug log and let's try moving my little guy around. All right, if you didn't do well in physics and you don't know what a vector is, you're going to have a bad time. But don't worry, they're not that complicated. Right, so if you think about 3D space, the scene here, okay? The center of the world is 0, 0, 0. Think about every single point in 3D space, right? It can all be represented as a line from 0, 0, 0 to the point that you're talking about. All of those different points, basically vectors, right? So you have a point in 3D space defined by 3 coordinates, x, y, and z. That includes the magnitude from the center, right? So in world space, really easy to conceptualize vectors. But then you can also think of vectors from every individual object. So, okay, if you're thinking about the player, and you're thinking about something that's 5 units in front of the player, well, that's the player's vector in world space. Remember, a line from the middle to wherever they are, plus a vector that goes 5 units forward relative to the player. things like that, okay? We'll get into some vector math in the script here, but let's start with the simplest kind of movement. Let's just move relative to these sticks. So we're going to create a vector 3. That's a vector in 3D space, so with x, y, and z coordinates. And let's go with just moving relative to the sticks. So remember our one stick, that's going to be the x-axis. We're not going to move on the y-axis at all. Don't have a up and down on the stick, do we? So we've got our x-axis movement, our z-axis movement, and then we're not moving at all on the y-axis. Okay, so let's try a really simple kind of movement. Let's go with simple move. All right, we have our controller locked in. We're going to do controller dot simple move, and we'll try feeding it our 2-move vector and see what happens. So it's the most fundamental move. You'll see this stupid example in all the Unity tutorials in the world. Let's go. Let's see what happens. Woo! Look at him go. And if that's all you need, then you're pretty much done there. And you'll notice if I very slowly march him over to the hill here, he just kind of wobbles his way up. Lovely. Automatically handles those steps. Isn't that beautiful? Okay, now that I've shown you simple move, forget about it. It's trash and never use it. But really, it's not very good. If you need only this, so if you need to just be able to move on the 2 axes, up, down, left, right, need to be able to handle some minor slopes. You don't want to jump, you don't want to dash, you don't want to do anything fancy. Simple move is good enough. For everything else, it's usually insufficient, and anything more complicated you want to add is just going to be more complex than anything else. But okay, so let's say we want to be able to move faster or slower. We'll leave simple move in place for now. Well, we want to be able to move faster or slower. We'll add a variable called move speed. Make this a float. Okay, and I made it public. Lovely. And now I can go to my player controller in the inspector and designate a move speed. I'm going to set it to, let's say, 100. And if I want my guy to be able to move faster, well, when he's moving, I'm going to multiply that vector by move speed. What happens when you multiply a vector by a float? You're multiplying its magnitude. So you're taking a vector that's short. This vector, remember, the x and the y go from 0 to 1 because they just take input directly from the stick. And you're making it longer. You're increasing the magnitude of that vector. Okay, so when we do this, we're going to sprint like the speed of light. And we handle that slope like a champion, don't we? We just blitz right over it. Amazing. Now, this kind of movement is a bad idea. And the reason it's a bad idea is because, remember, the update function fires as fast as it can. And because it fires as fast as it can, your movement is now proportional to how fast the update function fires. That's something that you never want to do. So anytime that you move something in update, and remember this and keep it in mind, anytime you move something in update and you're not just giving it force as a one-time deal, you need to multiply by time dot delta time as you do the movement. Now, what is time dot delta time? If you hover over it, it says the interval in seconds from the last frame to the current one. Great, that means that the longer it takes for the frame to render, so because of whatever happened, maybe your computer had a slowdown, it was a hiccup, a lot of stuff happened on the last scene, the longer it takes for the frame to render, the more you're going to move on the next frame. And then the less time it takes for the frame to render, the less you're going to move on this frame. And that gives you some pretty smooth motion. You can get very far without implementing any time.delta time before you start to notice the wonkiness of doing without. But of course now I'm moving really gosh darn slow again because time.delta time is really small. So if I crank that move speed up, I can get back to roughly where I was trying to be in the first place. So let's go with 5,000 and see how that looks. Whoops. 5,000's a little much. 2,000. 2,000's looking good. That's about the speed that I wanted to move at. Great. All right, now if you'll notice when I close this, it reverts back to 100 because I was making those changes while I had the game playing. So I have to make those changes again when I'm done with the preview. All right, well, that's simple move. And we've already established again that simple move sucks for all but the simplest game. So let's try the alternative. Let's try move. Move actually allows you to control how many units the character moves in world space every frame. Simple move works by using speed, and the advantage to simple move is that you get gravity built in. You can't move on the y-axis though, that's one disadvantage. So you can't even do jumping or anything like that without some pretty elaborate tricks. But you can move forward, back, left, and right if that's all you need. Move lets you actually have fine-grained control over all of the different dimensions. So let's see what the difference is. We'll do move, time that delta time, and let's move again. Multiply the magnitude. All right. And I fell forward. I clicked the button twice. All right. Woo! Way too darn fast, right? So crank that down a bit. Let's go for 100. Now that this is no longer velocity-based, it's actually moving some certain number of units. Smaller numbers make more sense. Now you'll notice that my guy now floats. When you use move instead of simple move, you have to handle gravity yourself. This is the downside. Simple move cleared those slopes like a champion and went up and down using gravity like a champion as well. Simple move, you're going to have to handle all of the gravity on your own. So let's go down to, let's say, 50 or something. And let's make it our next business to handle gravity. Let's do that next. All right, so one of the rules with move is that you only want to call it once per update. And the more times you call it, the more you risk having like a jittery motion where it kind of oscillates forward and back because the different moves are fighting each other on the updates. So just add all of your vectors together and then just do one move at the end. Remember, adding vectors, no big deal. They're just adding magnitudes. Sweet. All right, so let's handle gravity first. We'll call this gravity move. The gravity move isn't going to do anything on the x and z, but we want it to move on the y. And there's this constant that you can use in your scene, physics gravity, and that comes from your project settings as well. So if you go to your project settings and you go to physics, you'll see gravity here, and it's a vector just like everything else, and by default it's negative 9.8. Okay, so I'm pulling that. That's what physics gravity y is. All right, and so how do I add gravity to my existing movement vector? Well, it's a vector too, so I can just add them together, and everything's peachy, right? Okay, cool. So let's see if I actually fall to the ground as expected now. I'm climbing up and down these slopes. Well, I'm up the hill, and then I'm back down, and then I'm back up, and then I'm back down. Okay, cool. So that wasn't so bad, right? When I say you have to handle gravity manually, you probably thought it was going to be this big thing. Nope, it was pretty easy. All right. Sweet. We've got gravity. Let me slow this guy down. He's a little too caffeinated. Let's go to 20. All right, that's a little better. And you can see he's still kind of smoothly handling gravity. If I look in the game inspector window versus in the game, you can see he kind of clears these slopes, and sometimes he bobs up for a second because he's kind of floating in space for a bit, and if you move really fast. All right, there you go, cool. So he handles gravity, he can clear all these slopes, everything is peachy. But right now he doesn't face the direction that he's moving, which is kind of annoying, right? We want his hands to face in the direction that he's moving, which means that we have to deal with rotation. Rotation, unfortunately, is definitely not easy to do. Rotation involves quaternions, and quaternions are a complicated math concept that I really advise you not to get into. I advise you to just kind of learn them intuitively, but don't dive too deep into what they are because it doesn't really matter. A quaternion just represents your object's rotation in 3D space. And the reason that we have to use quaternions instead of just using Euler angles like this is mostly because of a phenomenon called gimbal lock, but also because quaternions are just a lot more efficient. And once you've worked with them for a little while, you'll totally get used to them, and you'll see that it's pretty awesome. All right, let's try getting our guy to face the direction that we want him to face. Okay, so first, we're going to make sure that you're actually moving, so let's... All right, before that, let's face the direction that you're moving and not the direction of gravity. We don't want you pointing into the ground. So we'll go with vector 3 to face equals to move. We'll lock it in before we add gravity, because if we add gravity to the direction we want you to face, well, you're going to stare at the ground too. So we just want you to move in the direction of your input, not necessarily in the direction that you're moving, including gravity. Okay, and we want to make sure that you actually have a change, that you're actually moving at this point. So we're going to make sure that to face is not 0. There's a convenient constant, vector 3.0, that avoids you having to create a new vector with 0, 0, 0 on all 3 dimensions. We're going to rotate this transform. I was able to access this transform directly. The transform is the transform of the thing that the script is attached to, so this guy. This is the only component that you get to access without having to do a get component call, because everything has a transform, right? Every single thing in the scene, except for the scene itself, has a transform, so there's no need for a get call. The transform is always loaded in. It's always the transform that the script is attached to. If you want to make it more explicit, you can say Gameobject.transform. The Gameobject is always, again, the object that this script is attached to. So we're going to take the transform, and if you hover over rotation, see it's a quaternion. Oh boy, isn't that fun. And we are going to look in the direction of that movement vector. So if you think about in 3D space, if you're moving, let's say, left, it's going to be over here somewhere relative to the character, right's over here somewhere relative to the character. So we just want to rotate this cylinder relative to that vector that we're moving towards, which is really on this 2-dimensional plane directly in front of our guy, or at least that's how we can conceptualize it. So quaternion has this lovely function, look rotation, and we're going to look at that vector. So that gives you an angle that is facing the vector that you want to look at. Let's see how this looks. Da-da-da-da, da-da-da-da, da-da-da. Look at that, my hands are facing the way I'm moving. Isn't that awesome? Except it's kind of dumb looking, isn't it? As soon as I hit the key, they just instantly teleport to the other side. I mean, that looks kind of goofy, doesn't it? So it's fine, right? I mean, it's workable for a game. You could stop here and essentially keep going until later. But let's say I want to be a little fancier. Let's say I want the hands to rotate gradually towards where I'm trying to look at. Okay, so let me comment this out and do something else. Let's say I want to gradually rotate towards where I'm trying to face. Okay, well, if I want to gradually rotate towards it, then I need to find an angle that's between the angle that I'm at now and the angle where I want to be, and then I want to gradually rotate you towards that. And for that you have 2 choices. The more simplistic one is rotate towards. Rotate towards takes angle A and angle B and rotates between A and B by some number of degrees. And so we're going to add another variable here. Let's add rotation speed so we can control how fast this happens. Rotation speed. So I want to rotate between where you're at now. That's going to be angle A. So we're starting with where you're at now. I want to look towards the place where I'm trying to get to. That's quaternion, look rotation, and then the direction that I'm trying to face. So that's where I want to end up. And then I want to rotate towards it gradually. So let's go with our delta time, always. Remember, anytime you're moving anything in Update, times our rotation speed, and I'm going to multiply by 52 just for fun. I'll make it move a little bit faster. And I missed a parenthesis somewhere. No, I didn't. Did I? Oh, I missed a comma. Perfect. All right. Okay, so this sets your rotation between those 2 coordinates. So let's pick a rotation speed. I'm going to go with 5. See how that looks. And now let's see how it looks when I do it. Okay, so see now I'm gradually rotating towards the direction I want to face rather than just latching onto it instantaneously. But you'll notice that the rotation is kind of robotic. Rotate towards, remember, it moves a fixed number of degrees every frame. So it's always the same speed. So it kind of looks like a servo arm when you're rotating. It just kind of goes at a set velocity, you could say, when it's rotating. What if I wanted to do like a more lifelike rotation where it starts out really fast and then it kind of slows down towards the end as you brake? That's how people actually tend to rotate. That's how most objects tend to rotate. So I call this one, the one we've done right now, kind of robotic rotation. Let's go with a lifelike rotation. So rotate towards is one of the most important quaternion methods. Definitely remember it, getting you between two angles. The other one that you can use for rotating between two angles is Slurp. Good old Slurp. And Slurp stands for spherically interpolate between points. Now if you imagine a set of two quaternions as 2 points on a sphere, so angle A is 1 point on a sphere, angle B is another point on a sphere. And you want an angle that's between points A and B on a sphere. Slurp takes that curved line that's along the surface of the sphere and finds a point between A and B where that third argument is what percentage between A and B you want to be. Okay, that was a lot of math to throw at you. So you have point A and B on the sphere, you have the curve that's between them, and then the angle C that you're getting out is a point on that curve between A and B, where 0 is A and 100 is B. And then everything in between is what you get with Slurp. Now, what you'll notice, if you do the math, is that as you get closer to B, so as A moves up towards B, the size of that curve gets smaller and smaller. So the distance between A and B gets smaller and smaller. And that means that it's going to move more slowly towards B the closer that you get towards B. And this gives you that natural rotation between two angles. All right. And yeah, don't forget, I'm going to upload all this code with comments at the end. I already have the originals done with comments, so don't worry if you're not totally following along here. So Slurp slows down as you get closer to the other angle. If you want more realistic effects, like start fast, go slow, go fast later, you can adjust that third argument as you go too. So this is how you get really fancy rotation effects that go at different speeds and more lifelike effects in general. All right, so Slurp doesn't need as big of an argument, so I'll remove the times 50. This is just between 0 and 100. It would just rotate too quickly, but you'll see anyway how fast it goes without the times 50. So with Slurp, you can see now that the movement is less robotic. It kind of starts fast and then slows towards the end. This looks pretty darn realistic, and this is good enough for like 99% of games. I mean, this already looks pretty realistic, right? You go fast at first, and then you slow towards the end. Fast, and then slow towards the end when you walk in. Pretty cool, right? Okay, now the problem with this is that when you start moving, you're kind of facing backwards, right? And with Slurp, now you're not facing backwards for very long. You just kind of instantly snap to the 90, which is a little bit more realistic, and then it slows as you get towards it. But it's still kind of weird that when you start moving, you're moving at the same speed as when you're facing forward. Most things start to move faster once they're facing forward. So we can play with this to reduce your move speed when you're not facing forward. Let's play around with that. Okay, so before we actually move you, we're going to play around with your movement speed in order for you to move slightly slower when you're not facing perfectly forward. All right, so we'll do it before the movement happens. So first, let's calculate how far from forward away you are. And we'll do that in degrees. In either chat, if you're still listening, which is probably a minority of you at this point, but tell me, what is the largest angle you can be away from forward? What's the maximum angle you can be away from forward? If you're thinking about it in 2D space, so just left, right, up, down. What's the maximum angle you can be away from forward? And the angle away from forward, we're going to use a Vector 3 tool here, which is going to give us the angle between 2 points. So we're going to get angle, and we want the distance between to move versus forward relative to our player. So we have our vector that's determining which direction we want to move in, and then we have true forward relative to the player, which is always transform forward. Again, transform forward is the same thing as blue arrow here. So not the difference. And some people answered 180, which is right. You can only be at most 180 away. So let's call this constant. We'll call this max angle. That's 180 F. I always like to put the F's on the end of my floats, even though you don't have to when it's implicit. It's just clearer for me, but not every situation do you have to. All right, so I want to modify your speed depending on how close you are from being forward. So let's call this speed mod. The closer you are to being forward, that's the closer you are to 180. So we're going to subtract the angle you're actually at from the max angle, and then divide by the max angle. That gives us the percentage that you are relative to being true forward. And then we're going to modify your movement relative to that. So we'll call this, let's just edit to move. So to move equals new vector 3. And the reason I'm making a new vector here is because I don't want this to slow down gravity. I only want this to slow down your movement in the x and z directions. So I'm going to take your x and z component of to move, and I'm going to modify it by speed mod, but I'm going to leave the y-axis component the same. To move.z to speed mod. So I've multiplied the x and the z components by the speed mod to reduce their speed, but I didn't multiply the y-axis by speed mod. Let's see how this works out, if I did the math here correctly. Alright, so now you move a little bit slower when you start out, and if I really crank down the rotation speed, let's go 0.1, and then I try to move in the completely opposite direction. I move kind of slow, kind of hard to tell, but you move a little bit slower, I think. So, yeah, move a little faster, and then a little bit faster, and then so on. All right. Actually, I might have got the math backwards here. You might move fastest backwards. I'll let you think about it. In spirit, it's accurate. Anyway, okay. So that gives you a slightly more realistic motion. Again, we're letting you move slower when you're not facing the direction that you want to be going. Cool. Let's see, what's next? We got facing direction like a robot, moving faster when you're facing direction you want to move. Okay. Oh, here's a good one. When we go up and down hills, right, when we go up and down like this hill, our little robot arms just stay in front of us, and that looks kind of stupid. When we go up and down the hill, our character really ought to curve up and down relative to the slope that they're sitting on. Okay, well, how do we decide how much you should look up or down? This is actually a really hard question, so let's look at one possible solution. Getting this right is something that would probably take you, I don't know, many hours of tinkering with it, but let's look at a simple, kind of not so great solution that at least gets the job done. Okay, so if I was to decide whether or not I want you to kind of look up or look down because you're on a slope, the first thing I might look at is, do you have velocity on the y-axis? So if you look at the character controller, look at our delta in position, actually, let's look at that. We see that when we go up and down the slope, our y position changes, which means that we have velocity on y as we're going up and down the slope. So we could look at just the change in position, but it's hard for us to get a delta here on update because we only see what's happening this frame. So we could save the y position in the last frame and then see if it's changed in this frame. That would actually probably be the best and smoothest way to look up towards the slope. But a little shortcut we can use is that we can just look at the velocity. So we don't want to look up and down if there's like a really small slope. So let's say the minimum is 0.5f. Before that, we don't want to look up and down. And we want to look at the character controller. So that's our character controller, and see if it has velocity on the y-axis. And if it does, greater than the minimum slope magnitude, then we're going to look up. Alright, well, how do we look up? We have this to face thing here. So let's actually put that code down here. And I split all of this into functions when I'm uploading the example for you, so don't worry, it's not going to be commented out garbage like it is here. So what I want to do is I want you to face a little bit further up than you are now. So let's say I take the vector that I want you to face now, and I'm just going to add some small amount, let's call it 0.5f in the y direction. So now you're looking slightly up from where you were looking before. And I'll do the same thing the other way. Alright, so if it was less than the negative, I'm going to have you point down slightly. So when you descend slopes, you'll kind of look downwards. Alright, so let's see if this, whoops, let's see if this was enough to let you kind of look up and down slopes a little as you walk. Oh, look at that. My hands go up, and my hands go down, and it looks kind of realistic. It's not great, but again, for most games, this is pretty passable, and you get kind of this weird up and down motion when you descend a bumpier slope like this. But generally, you're facing the direction of the slope as is expected. Remember I told you earlier we turned off the capsule collider? Well, if we turn it back on here, we'll notice that nothing really happens. The character controller takes precedence when it's attached, and this is actually going to have it be pretty difficult for you to do certain interactions in your scene with character controllers. So we'll look into one with the time we have remaining, and that's jumping. So I told you that you have to manually handle gravity. Well, the downside to using move and a character controller is that you also have to manually handle jumping. And since you can't just add force to the character, which we'll see next time is a lot easier to do than this, since you can't just add force to your character directly, we're going to have to handle the whole jump curve manually. Remember, when we call move, we're actually just telling it how many units to move at the end of that frame. That means that we have to tell you how many units to move at the end of every frame of the jump. So there's a curve, right? You have a lot of energy at first, it builds up, you hit a peak, and then you come back down again. We're going to have to handle that whole process manually. And this is going to be true of any other cool physics thing that we want to do, like dashing or teleporting and stuff like that. Yeah, it's going to be a pain in the butt to do any of that stuff with a character controller. That's where physics-based controls is going to be a lot more useful. Alright, let's start with... Well, let's start with a bad jump, and then we'll move from there. Okay, so we're going to have a variable that determines whether you're allowed to jump or not. I'll make it public so that we can see the checkbox in the editor, and it's going to be is grounded. If you're not grounded, you shouldn't be able to jump. You can implement this as like a double jump or something too, by just making it, instead of a boolean, making it an integer, and rather than setting it to false, just depleting it by 1 every time somebody jumps. So what we're going to program here, it's fairly simple to convert it into a double jump if you want people to be able to jump in midair. Okay, so if you are grounded. Okay, if you are grounded. Well, we want a button. So let's go with input dot, rather than an axis, we're going to do get button down. This is when a button is first pressed, and we'll use the jump button, which is one of those built-in ones from the already inputs there. So if your jump button is pressed, which is space by default, and I think A on the controller, and you're grounded, then we're going to execute a jump. So let's do our move at the very end. Actually, let's just move jump up. I want to do all the different facing stuff at the end. Deciding what order everything happens in update, whether you're going to move first and face first, this is something you're going to have to play around with sometimes too. And this is something I'm not sure about either. Do I want to jump before I determine your facing angle? Because I've locked in the facing angle up here. If I want you to look towards the ground or up into the air when you jump, I'm going to have to make further modifications and change the order of this stuff maybe. Okay, so if I just want a really basic, stupid jump, let's say toMove plus equals new vector 3, and we'll do 0f, we'll do like 100, it's probably too much, 50f, 0f. Alright. So really simple jump. Let's see what that looks like. And it's not going to be good, let me tell you, because it all happens on one frame. You just jitter up, and gravity quickly descends you back to the ground. It looks awful, doesn't it? Let's see what happens when it's a higher number. What if it's like 500? This is going to send you into the stratosphere a bit, but I guarantee you it's going to look no better. Here we go. Since it all happens in one frame. Looks stupid. Okay, so since we're using a character controller, we have to manually move you slowly towards the peak of your jump, and then manually move you back down. So when you start to jump, we're going to lock in this other variable. Go with Boolean is jumping, and this is going to handle your ascent and then descent. And then we're probably going to have another one, is peaked or something like that. Let's call it jump. That's what I have in my notes. And that's going to enable you to go back to the descent. Okay, so as jumping is false, jump peaked is false, and then once you hit the old space button there, we're going to set is jumping to true, and then we're going to calculate your jump curve accordingly. We have a few minutes left. If there's no questions, we'll get started on it, but we're probably not going to finish it today. We'll resume the jump curve thing next time. Okay, so to start your jump curve, let's see, you're going to need some kind of tracker for your current power in the jump curve. I'll call it jump curve. Alright, and when you first ascend from the ground, you are jumping. Your jump has not yet peaked, and the original power we want to start you off with is going to be just enough for you to get airborne. So we're going to take the opposite of gravity, and we'll add some small amount to it so that you can actually get airborne within this frame. So you're countering the gravity that gets put on you on every frame. You're going to go slightly higher than gravity. And we'll go for if you are jumping. Alright, if you have not peaked, jump peaked. Right. If you have not peaked and your jump curve is less than, let's designate a variable for peak power. That's going to be public so that we can determine how far you can jump. So we'll call this jump strength. Jump strength. And this is going to be the highest amount that you can get to, or the highest amount of force you can have. So let's say your current jump curve is less than the jump strength. Then we're going to add to the jump curve. And then on the other way, we're going to subtract from it. So we're adding to the jump curve on the way up. So plus equals, anytime we're doing anything with movement, remember we involve delta time in there. And this is going to be, let's do another constant. So how fast your jump builds and decays. I think I had a factor for this, a good one. So let's call it private float jump decay rate. All of this just for a simple jump because we opted for character controller. Gross. All right. Okay, so we're going to add, based on the delta time and the jump decay rate. Okay, and then we'll just add that to move. So it's new vector 3. This only affects, what do I do there? New vector 3, and this only affects our y-axis movement. Okay, and then if your jump curve has exceeded the jump strength, then the jump has peaked, and then we're going to start our descent from there. So we still have to do next time the descent functionality. Let's see what it looks like. Assuming that I didn't make any mistakes here. Let's see if you have a good ascension curve. You're just going to fly into space right now with no descent, but let's see. Oh, forgot to actually set jump strength to some values. Let's go with 10. Well, something happened. Let's go with a higher value there. Oops. Whee! Goodbye! My people need me. Well, it's smoother at least, even if it does send you into the stratosphere. So that's all we're going to do today. I will upload the real version of all of this stuff probably at the end of the day today, but we'll keep working on it next time. If you have any questions, hit me up in Discord, and I will go into Discord to talk to your teams if you have any team-specific questions here too. So thanks for tuning in. See you next time.